On my screen, I have the crankcase for the Radial engine. This is where we left off last class. And looking at the part, the model appears to be complete. So what I'm going to do is I'm going to go to the level manager. You can currently see that I don't have anything. I don't have any levels made. So I'm going to create my default levels. And then I'm going to organize my work. I want to put things on the correct level. That way I can make things invisible and, unclutter my screen. So let's do that now. Let's start by creating the default levels. And level 1, I will call this solid support geometry. Basically, every piece of wireframe geometry that's on my screen is used to create the solid model or used to support the solid model. So I want to put that on its own level, make it invisible. I want to protect that geometry. So I have one level, 44 entities reside on that level. Let's start by giving it a name. Call it solid support geometry. Now, if you can't remember what the default levels are, you can look back at previous projects, go to the project page for something that we did earlier in the semester, and that'll give you an idea of what the levels are supposed to be. So let's do that. Let's go back to the project page in Canvas, and I'm just going to look back, as far back as, say, drill project 4, the discussion. And I'm just going to reference this image of the level manager. These are the default levels that we'll use. And on occasion, we will add more levels to this list, but these will be the basic ones that we use more often than any other level. So I'm going to reference this menu or reference this image to create all my levels. So back in Mastercam, I've already got level 1, solid support geometry. To create a second level, I'll select create new level or add a new level. We'll call this one solid model. Create a third level, I'll select the plus sign. I'll call this one wireframe from solid. Create a fourth level, I'll select the green plus sign, and we'll call it dimensions. Let's see this level. Let's go to level 5. Call this points. Create a 6th level. We'll call it material. And we'll create a 7th level. And we'll call it name. Now, this is a little bit different than what we've done with previous projects. For me to apply dimensions to this part, I'll have to change the construction plane several different times. And it might not be a bad idea to create levels for each of the dimensions or each group of dimensions that reside on a different construction plane. That wouldn't be a bad idea. I'm not going to go there right now, but we're going to place all the dimensions on one level. And if it gets too cluttered, then we might create those additional levels. So I want to start by dimensioning the geometry on the front face. And if I look at it from the default isometric view, I'll have to change my construction plane to the right side. I'll go to C plane, and you can see it's already set to right, but if it wasn't, I'll just select right, make that the active construction plane. If I look at it from the right side view, I can apply dimensions to this geometry. And these dimensions that I'm going to create, they're not for the generation of an engineering drawing. We're basically using these dimensions to double check to make sure that our geometry is correct. So I'll start by making the wireframe color something that I haven't currently used, or something that's currently not being used on my screen. And then I will open up the blueprint again. Now I don't have it open, so go back to my downloads. Open up the engineering drawing. I'll have that visible on my screen, and I'll reference that for the dimensions that are being used. So how's everyone doing up to this point?
Okay.
Nice. Something I haven't done yet. Make the dimensions level the active level. Anything we create goes on the current level or active level. And where is the blueprint? There it is. All right, so here's the blueprint. And I'm going to start by creating the dimensions in this view. Basically this 4-inch, this 1/4 inch, and this 4.25. So I'll go to drafting, smart dimension. I'll select this line, and I'll select this line. I'll pull the dimension off to the left. To flip the arrows to the inside, I can hit the A key, or I can come over to the leaders, and the arrows, I can change them from the inside to the outside, whatever option works for you. I'm using the inside. I'll place a dimension. I also have a dimension on this construction circle. That's 4 inches. And then this fillet right here. I'll flip the arrow, I can hit the A key, and that'll be a 1/4 inch. Select OK to exit the smart dimension tool. And I can reference the blueprint to make sure they got all the dimensions that are called out. Now, I could call out, or I could dimension the hole that we used to position these drilled and countersunk holes. So let's do that. Let's go back to Mastercam, smart dimension. And if I select this circle, I was locking onto the quadrant. Now I need to be careful with this because this particular circle we use to position the hole. Now, if it doesn't match the diameter of the hole, it's actually in the solid model. That could be a problem. I'm trying to lock on here and it's being somewhat difficult. There we go. All right. Now here's something we got to watch out for when we tumble a view. The geometry might be, might be at a different Z level, but in this case, it looks good. So I'll go to a front view or right side view again. Go back to the blueprint. And I've got everything in this view. Now, something that I can do, this 3.5 dimension, I could dimension it in this view. So let's do that. Let's go back to the Mastercam. I'll go to the smart dimension tool, and I'll select this circle right here. And that's 3.5. So we're checking our work. We're not actually trying to create an engineering drawing. So in this case, I think I've got all the dimensions from this view. How's everyone doing? All good? All right, cool. Let's do this. Let's go back to the drawing. Let's create the dimensions that are in this view right here, the top view. So I'll go to SolidWorks. I'm sorry, I'll go to Mastercam. This time I'm going to change my construction plane to top. And then I'll look at it from a top view. Now the orientation of our part is slightly different than that of the blueprint. Not a big deal. So from here, I'll go to the smart dimension tool. The diameter of this reference circle or bolt circle, 1.8. The distance from this edge to the center is going to be 1. The distance from the center to the center, that is also going to be 1. And if I go back to the drawing, I've got the diameter of this hole and the diameter of this hole. Let's call it. So I can select this circle, and I can select this circle, pull the dimensions off of the part, and I can fit the screen.
I have a question.
Yes, sir.
Mine's saying that it's giving me a warning saying the construction plane is perpendicular to the graphics view.
Did you change the C-plane to the top, or are you still in a right side C-plane?
I got it. All right, for sure.
All good? Yeah, so that's if the construction plane's weird or not correct, it's going to give you that error. All right, so I think I've got all the dimensions from this view. I'll go back to the drawing. We need to, oh, there's a double dimension there. I didn't see that. So this 4.25 already exists here. So technically this should be removed from or be in parentheses. So this dimension is not correct, but it's not hurting the drawing, but it's not correct. All right, so from here, let's create the dimensions that we see on this back view, or call it the left construction plane. Back into SolidWorks, go back into Mastercam, change the C plane to left, and then look at it from a left view. Now, there isn't a left view available. There we go. So G view left. There we go. Had to expand the menu. So when you right click, the left WCS isn't available, but if you go to G view left, it's available there. And I've got my C plane set to left. So now I'll go back to the drawing. Let's create the 1.75, 0.531, and the 3. And then we've got this 0.188 diameter hole called out here. Then I've got this 201 diameter hole for the drilled and tapped hole. So go to Smart Dimension tool. I'll dimension this circle, 3. I'll dimension this circle, 1.75. Let's see here. What else we have? The diameter of this hole. Let's try to lock on the center. So I'm going to move it around until I get the, not there, not there. It's not cooperating. There we go. So locked onto the edge, 0.531. I'll just pull that off of the part. And then I've got the diameter of this hole, diameter of this hole or this circle.
Oh, I see what I'm doing wrong.
And don't be concerned about, the drawing or the dimensions not looking like the blueprint. Once again, we're just checking to make sure that our model's correct. When it's all said and done, we're going to make the dimension level invisible. And if I go back to the blueprint, I think I have everything. All right. Now I've got a couple of dimensions. I didn't get the ones on the inside of the part. I'm going to go back to the right side view and dimension this hole right here. I go back to Mastercam, change my construction plane back to right, and then look at it from a right view. I need to dimension this circle. So select the circle. Now you see how the C plane is still set to left, so I was reading backwards. So set this to right, and then do it again. How's everyone doing?
Okay.
Yeah, it looks a little strange because I created some of the dimensions on the right side construction plane and then some on the left side construction plane. And you can see that the dimensions that are on the other side aren't reading correctly. They're reading backwards. So far everything is checked out. The only thing that I really haven't dimensioned would be the thickness, the depth of this pocket, and then the depth of this pocket. We can try and do that. We'll see what happens. If I look at it from a default isometric view, the back plane is the one that I'm going to want to activate. Actually, let's back the front plane. Make the C plane the front. And then if I go to a non-shaded view, let's go to, let's see here, this one. Oh, that's too much. Translucent might be the way to go. So I'm looking at it from a translucent view, and then I'll look at it from a front view. This might be a little difficult to lock our dimensions onto.
I'm having a hard time, like, when I'm clicking on an arc, like a circle.
Yeah,
like it's wanting to give me like the radius.
Yeah, it's trying to give you the radius.
Yeah, it's only half the
oh,
circle.
because it's locking onto the center point. Can I see your screen for a second?
Yeah.
Yeah, so you got to be careful not to let the auto cursor grab a quadrant or the center. So try to approach the circle, say from, between the quadrants. So if I can see your screen, I can give you a little bit of guidance on that.
Yeah, I'm trying, but
oh, my bad. That's on me again. All right, let's do this. Try it now.
Okay.
Okay, so hit escape.
Trying, it's not working.
Click on the top of your screen. Okay, hit. Yeah. Okay, now go back to the smart dimension. Not that you can't select that edge. That's a solid edge. Select. Now it's trying. There you had it when it said E. Don't left click now. When it says E, move your cursor until you see it E. Keep going. Keep going. Go towards the bottom. There you go. Right there will work.
All right.
So yeah. So if it's the auto cursor is trying to grab onto the center or a quadrant, the 12 o'clock, the 3 o'clock, or the 6 o'clock. Move your cursor around until you see it grab an edge, and then it'll give you a diameter value dimension.
All right, thank you.
Oh yeah, that's good. All right, so these next 3 dimensions will be a little difficult to create. Go to smart dimension. I'll select this endpoint and this endpoint. It's hard to lock onto. I got it right there. Now it's not correct. There we go. And then I had to shift it a little bit. So I'll place it, and then I'll select it again and move it. And when I did that, it lost one of the arrowheads. So I'm going to have to, let's see here. Witness line, I want both. So I lost one of my arrowheads. I'll probably have to fix that at a different level. So what I'll do is I'll continue placing these dimensions. And once again, we're using these dimensions to verify that our model is correct. Not too worried about how it looks, just create them. And then we're using them to verify that everything is correct. And I want to go from center to center here. And this one's a little difficult to see. Select OK. Now I'm missing arrowheads. If I select it, hit F4. There we go. What I'm doing is, because it's missing an arrowhead, I select it. I hit F4 to access the attributes or the properties for this particular dimension. You can see that one of the leader lines is hidden. So if you see a red X, make it visible. Got it from an isometric view. And it got cluttered pretty quick, but everything on my model checked out. And that's all we're using these dimensions for. So from here, I'll make the wireframe from solid level the active level. I'll make the dimensions level invisible, and then I'll make the solid support geometry level invisible. And when I do that, you can see that my solid model disappears. Reason being is I need to transfer my solid to the solid to level 2. To do that, select the solid model.
Yeah, no idea.
And it's bringing up the parameters for the solid. So let's do this. Right click, change level, select the solid and selection. And I'm going to move it to level 2. Now you can see I have one entity on level 2. I'll make the solid support geometry level invisible. I'll go back to a non-transparent view. And the only thing that I should have visible on my screen at this time is the solid model. So if I go to Home, Statistics, the only thing currently visible on my screen, one solid. Select OK, and then I'll save my work. So how's everyone doing?
Pretty far behind.
Okay, yeah, and remember, this is an extra credit part, and this is the applying the dimensions here. It's just something that you're going to have to work through. It's a little challenging because we haven't done it before, and just being comfortable, selecting things and getting the dimensions to, appear the way you want them to.
Yeah, it's hard to. I mean, I'm stuck on the front view.
All right, can I see your screen?
Yeah.
I'll try to give you some guidance on this one. All right, so construction plane. What's your C plane? It's at the top. So set your C plane in the front. Now go to the Smart Dimension tool and zoom in on that front corner or the top right edge. There, right there. Lock onto the endpoint. Yep, you had it right there. Endpoint? No, endpoint.
Okay.
Perfect, right there. And now go to the endpoint. Nope. Left side of the part.
Left side?
Yeah, so go up at the go up, right? That endpoint, that's the midpoint. Hit escape. So hit the endpoint. That's the midpoint, but it might work. So you see the preview on your cursor, right? That's an endpoint right there. Yep. Left click.
Yeah.
Now go to the bottom of the fillet. That's an endpoint. Left click.
Oh, okay.
And actually that was a midpoint, but now if you zoom out a little bit, roll your scroll wheel and position your cursor so that the dimension goes vertical. You're fine. Position the cursor. Yeah. Let's see here. Drag it to the right. Drag your. It's not playing ball. Can I take control of your screen real quick?
Yeah.
All right. So. Yeah, and it's not very forgiving. So don't let it get to you. So if I go to Smart Dimension, I'm locking onto this endpoint. Then I'll come over here. And I want to, it's trying to lock onto different things because it's a 3-dimensional model. I'm going to try and get endpoint right there. Left click. Now the dimension is, you see how it's kind of a diagonal dimension?
Yeah.
So let's do this. We're going to try a different method. We're going to go to horizontal. Then lock onto the endpoint. Lock onto the endpoint or midpoint. It doesn't matter at this point. And it creates a horizontal dimension. It can't rotate. I'll flip the arrows. Oh, I didn't want that. So off to the right. Looks good. And we need to do the same thing here. You can barely see it. So I go to Smart Dimension, Endpoint. This will be a quadrant. Drag it off to the right side. It wants to tilt when I'm to the left, but if I drag it to the right, see how it straightens out?
Yeah.
And one last one. We're going to go from, let's see here, the center to the center. And that should be 0.3. Now that's, the depth of that's incorrect. So what we can do is, because it should be 0.3125.
Mm-hmm.
So let's do this. If I tumble the view, and this was a cut, right? So if I go back to view, and then I go to the solids manager, oh, not planes, solids. Nope, not that one. Extruded cut, this guy right there. Right click, edit parameters. That's correct. I must have locked onto something incorrectly. So that is correct. The extruded cut distance is correct. Select this. Close out of that. Go back to a front view. Oh, I see why. It's slightly rotated. Try that one more time. So go back to wire, or my bad, drafting, smart dimension. Got it, I see. Yep. It's this one right here. There we go. All right, so Josh, you're good.
All right. Thank you. And so,
Welcome.
like,
It's just you got to get in there, and you really have to. Sometimes dimensioning inside of Mastercam can be a struggle.
yeah.
So, and
just
they don't need to be pretty. We're just checking our work with them.
Okay.
All good?
Yeah, I'll just move on. I'll do this part later, I guess.
Yeah, you can revisit it. Everything's got there'll be videos for everything.
Okay, and then we're just making our solid, like normal or what, or like
We're
right?
gonna, we're gonna make material that's gonna be cylindrical this time, so it's gonna be a little bit different. All good?
How'd you just make your solid model though?
What's that?
How did you just put your what did you just move to your solid?
Move to I selected the part and moved it to level 2.
Okay.
Yeah, it was real straightforward. Just right click on your screen, go to change level, select the part and selection, and then move it to move to level 2.
Okay.
Good?
Yeah, thank you.
You're welcome. How's everyone else doing?
Okay.
Nice. All right, so from here, make the wireframe from solid level the active level, and change the wireframe color to something that you haven't used yet. So I'm thinking, let's see here. What can we use? I've got red, and I think I've used green. So I'm going to try using this color right here, this red, this burgundy color. I'll go to wireframe, curve all edges, and then I'll triple click the part until the entire part becomes selected. And then I'll select end selection. You can see edges being created on the entire part, or all the edges of the part. Now, if it doesn't look correct, there's a good chance that it's set to 2D instead of 3D. Make sure it's set to 3D. And if everything looks correct, select OK. Look at it from an isometric view. And if I make the solid model level invisible, I've got a 3D representation of our part built from wireframe geometry. Now, I like to keep both the solid model and the wireframe from solid level visible. Depending on the different types of toolpaths that we use, I might be selecting solid geometry and I might be selecting wireframe geometry to drive my toolpaths. So from here, make the material level the active level. And this would be a good time for us to save our work. So file, save. How's everyone doing? Doing good?
I'm missing wireframe geometry.
Okay, can I see your screen?
Yeah.
All right, let's see what you got. Levels. Interesting. Yeah, I've got 238. You've got do me a favor, make go to your level manager. Make the solid support geometry level invisible. Okay. Make the dimensions levels already invisible. 216.
Is that because I didn't finish my dimensions, or?
No. It's usually because it's missing something. That means when we created curve all edges, it just created arcs, lines, circles, whatever it needed to create a curve on all edges. So it's something's missing, it looks like. But I mean, that's because there is because you have a fewer number of entities on that level.
Yeah.
I suspect something's missing, but everything looks to be there. Now, something you can do, go to the inside of the 3/16 diameter holes.
Which are?
On the back of the part. And look inside. Now, something that might have happened, if the diameter of the holes are different, I might have created more geometry than you. So select one of those red circles and hit F4. Yep, select that circle, hit F4.
Oh, I can't hit F4 because
or go to Home, Analyze Entity. Home, Home tab, Analyze. So it's 0.188. Go okay, exit there, exit out of that, and then zoom out and select tumble so you can see one of the holes on the top of the part. And you're going to analyze the 0.188 diameter hole on the top. So go to, you can select it, select that 0.188 diameter hole, not that one, that's a 201. Those are 201 diameter holes. The 188 is that one right there, yeah. And that's also 0.18. So that's probably what's going on, because I've got my one at 0.188 and 0.187. And what it's doing, let me show you my screen again. Let's see here. Because of what I did, can you see my screen?
Yeah.
If I zoom in, you see that piece of line geometry right there?
Mm-hmm.
That's the difference between the hole diameters. If they were the same diameter, that wouldn't exist. If you zoom into yours, you probably have a point. Can you see that?
Yeah, I can see it.
Do you have a point there, or do you have a line drawn there? So anyway, it's not a big deal. If something comes up, if it makes itself obvious down the road, we'll deal with it.
Yeah, mine's a point.
Yeah, yours is a point. So you're going to have, let's see, I've got 6 holes times 2. So there's going to be 12 additional entities from my screen to your screen. So what do you have in this field? How many entities do you have on that level?
I have 216.
216. We're still off by something, but don't worry about it. It's not a big deal.
Okay.
All right.
Yeah.
All right, cool. So if everyone's good up to this point, what we're going to do now is we're going to make a solid that represents the material that we're going to machine this from. And we're going to machine this from a piece of material that's 5 inches in diameter. So this is going to be different than what we've done in the past. The material will be 5 inches in diameter, and the length is going to be, let's see here, 2.625, I believe. And let's say I will make it 2.75. So we'll make the material 2.75 inches in length. And let me do something real quick. So the overall length of the material is 2.25 plus 0.02 plus 0.375. Yeah, we'll make it out of 2.75. All right, so we'll go back to Mastercam. Make the material level the active level. And we haven't put our name on it yet. We'll put our name somewhere on the part. So let's make the material level the active level and change the solid color to something that you haven't used yet. I'm going to change it to this purple color right here. And I don't know if that's a good choice of colors, but that's what I'm going to use. And then before we create the material, set your C-plane back to top. That way we're all on the same page. So C-plane, set it to top. The X-axis should be running through the center line of the part. How's everyone doing up to this point?
Okay.
All good? All right. So let's create the material representation of the part. You're going to go to wireframe, bounding box. Let's start by changing it to cylinder. And actually, we have to select what we want to create this bounding box around first. So select Control A. Make sure your dimension level is invisible before you select Control A. Otherwise, it'll create a bounding box around the dimensions and the part. So dimension level is invisible. Control A to select everything that's visible on your screen. Select End Selection. How's everyone doing?
Okay.
Good. For the shape, set it to cylindrical. Set the radius value to 2.5. And you can see that the axis is around the x-axis. If it wasn't, you could change it at this point. But it's currently set to X, and that's what we want. And make the radius value to 2.5. And then you want to select center axis. And then it changes the radius value on me again, so 2.5. So just to recap what we did, radius is 2.5, height 2.25, and this was something that Mastercam came up with based off of the thickness of the part. The axis, the center axis of the cylinder is along the X, and then I checked center on axis. From here, remember, we're going to make this from a piece of 2.75 thick piece of material or long piece of round bar. So I want to add 20 thousandths to this front face. That'll give us 25,000 or 20 thousandths to remove when we face the top of the part, and it'll give us a nice machined surface along this open face. So I'm going to select this surface. I'll hover my cursor over the arrow that appears. I'll type in 0.02, enter once, enter twice. I'll tumble my view. I'm holding the scroll wheel down and moving my mouse. I'll select this surface. I'll hover over this arrow, and the amount of material that I'm going to add to this side is going to be 2.75 minus 2.27. So what I'll do is hover over here, 2.75 minus 2.27, enter once, enter twice. Before I hit enter that third time, come down here and make sure that you've got the lines and arcs turned off and the solids selected. And then I'll select OK. Now I can't see my part. So what I'll do is I'll change over to a translucent view. And you can now see that the part is suspended in the material that we're going to machine this from. And I'll do this again. This is we haven't done this yet. This is a little challenging, so I'll repeat the whole process for you guys. Before I do that, though, is anyone having any questions?
When we look at the front face of the 20 thou,
Yeah. So if I look at it from a front,
it look pretty much like
should be like 20,000s from this edge to this front face.
okay.
Yeah, and we're just gonna take a face mill and take that 20 thou off.
Wondering if it actually went through or not. Looks pretty close, but it looks like it looks like there's material right there.
Yeah, if you look at it from a front view, you should be able to see the excess material. Look at it from a front view. It looks like you got it, but right click front view and then zoom in. Yeah, you got it.
Okay, thank you.
You're welcome. How's everyone else doing? You can see why this one is an extra credit bar. This one is challenging, to say the least. All right. So from here, we need to set up a coordinate system. If I look at it from a right side isometric view, hold on, I got a message. Did we switch to solid? Yes, we did, Tyler. So before you hit enter that third time or the green check, change from a wireframe to a solid. And let me redo this for you guys real quick. So I'll delete it, and I'm looking at it from an isometric view. We're going to use a bounding box tool to create a cylindrical shape that's going to represent our material. I'll go to make the material level the active level and change the solid color to something that you haven't used yet. I'll go to the wireframe tab. I'll use the bounding box tool. I'm just following the instructions that Mastercam is giving me. Control A to select everything. Control A. And then I'll select end selection. It's going to create a bounding box that, captures what we just selected. But if you look at the radius value, this is kind of an off number. I want to use a radius value that's going to represent the diameter of the material that I'm going to purchase. So 5-inch diameter material, that's pretty much readily available. So the radius of that is 2.5. If you need to change the axis, you can change it here. I've got center on axis checked. If you don't, it creates the cylinder and it's a little bit off center. So check center on axis and then change the radius value to 2.5. I noticed when I checked center on axis, it changed the radius value on me. So radius is 2.5, 5-inch diameter. The height is 2.25. That's the finished thickness of our part. I need extra material on one side so that I can face off material and get a nice machine surface on this face. And then on this side, I need excess material to hold on to in the soft jaws that we're going to cut to machine this part. This is a cylindrical part or a round part. You can't easily hold it in a vise. So what we'll do is we'll cut soft jaws, and the soft jaws will match the radius of the material. And that way we can safely hold the material when we're cutting it. So let's add 20 thousandths to this face. And it might be easier if I make the coordinate system invisible for the time being. So I'll go to View, toggle off Show Nomens. I'll select this cylindrical face. I'm sorry, I'll select this flat face. You see an arrow appear. And if I hover over the arrow, a scale appears, and then there's a window that I can actually enter information into. So let's add 20 thousandths to this face. So 0.02, enter once, enter twice. On the back side of the part, we need to add material to this face. Now, the current thickness of our material is 2.27. We added 20 thou to it. I want to make it the overall length of the material at 3.75. I'm sorry, 2.75. So I'll select this face. I'll hover over the arrow. I need to add the difference between the material length and the current thickness. The material length is 2.75. The current thickness is 2.27. So what I'll do is I'll hover over this arrow, 2.75. That'll be the desired length of the material minus 2.27. Enter once, enter twice. If you did it right, the height of the material should be 2.75. I'll come down here, I'll deselect lines and arcs, and then I'll check solids. And then I'll select OK. If I look at it from an isometric view, you can see the cylinder is laying on its side, and we need to change that. Okay, so did we switch to solid? Yes, we did. I'm looking at the chat room. Cool. So how's everyone doing? Any issues or any problems I can help resolve? All right. Let's do this. Tumble your view. We need to create a new coordinate system. And I'm going to place it or use this top cylindrical face to create that coordinate system. I want the z-axis to be perpendicular with this flat face, and the flat face that's closest to the opening on this part, because we're in a first operation, we're going to face the top of the part, machine the outside profile. We're going to spot drill and drill all the way through the part. We're going to spot drill and tap. And then we're going to machine this pocket, and then we're going to deburr the part. So there's a lot going on. And I need the coordinate system so that the z-axis is perpendicular to this flat face right here. So let's do this. Go to the plane manager. Go to View, Planes. Inside the plane manager, select Create a New Plane. And you're going to select From a Solid Face or From Solid Face. And then hover over the top flat face, select it. And you'll see that the z-axis is perpendicular to that top face. And that's what we want. And then we need to determine which direction we want the x to point. Either way at this point will work. I'm thinking the first option that we have, which would make this axis pointing to this edge right here. Either way would work, actually. If I moved it, that one would work also. They're all the same, actually. Well, they're not the same, but they would work similar. So I'm going to go with the first option here. And then I'll select OK. And give it a name. We'll call it first operation. Under set as, I've got WCS, T-plane, and C-plane all checked. And for the time being, I'm going to leave it where it's at. And I'll select OK. If I look at it from an isometric view, right click, isometric. And then if I go back to view and I toggle on the coordinate system, that's where my origin is currently located at. This would be a good time for me to save my work. How's everyone doing?
So which way did we set our plane?
Okay, so Z is going to be perpendicular to this top face, and X. Now remember, this thing it's symmetric. So I've got X pointing at X is perpendicular to that edge right there. See that?
I'm not getting that option. I don't think.
Can I see your screen?
Yeah.
Do me a favor. Go to view and go to show nomens and turn off use origin color. And interesting, why is it doing that? It's like T-plane. Yeah, you've got more than one axis showing. So deselect T-plane for now. Interesting. All right, do me a favor. Scroll through the that right arrow. Oh, you're all right. You're all right. So see the right arrow. So it says plane one. Yeah, scroll through that.
Mm-hmm.
Yep. And which one? Keep scrolling. I'm trying to figure out which one's moving. Like, go to option 1. That'll work fine right there. Hit the green check.
This one?
Yeah, hit that green check. Yep, that's what we want right there. And give it a name. Call it first operation. And it should be good. Select OK.
Yeah, it was hard to see that.
Yeah, and go back to your plane manager. Go to the 2 green arrows that are following each other, the follow rules. Yeah, that's all good. That's all good. Oh, wait a minute. Let me see something on mine. Yeah, yours is the same as mine. Yeah, it's all the same. We're all good there. Go back to that again. Yeah, I've got use origin colors checked.
Do you have selected planes checked?
No, I don't. All right, so you have the same settings that I do right now.
Okay.
All right, cool. All right, so let's go back to my screen. And we'll look at it from an isometric view. How's everyone doing? Doing all right? All right, so this next step is going to be a little difficult. And I'm going to try and get everybody through it. So if you're following along and you're at this level of completion, I'm going to demonstrate this. I'll demonstrate it a couple different times. And then we will, then I'll stop and I'll help you guys with any issues that you might be having. So if you were at the machine looking at this part and we're running this on the mill, it's not going to be run on the lathe. It's going to be run on the mill. There's a lot of milled features on here that can be, it could be a mill turn part, but it's a hexagon and it's got a circle board in it. So for the most part, everything's gonna be done in the mill. How would you hold on to this part on the machine or at the machine? Could you hold on to it in a vise?
Maybe a fixture, I don't know.
Yeah, so what we do with this part is we take a soft jaw. Now we've made soft jaws, right? We've remember the mill soft jaw project?
Yeah.
Those are designed, or those are the intended use of those is to cut a profile into the aluminum jaw so we can hold on to oddly shaped profiles or something that won't be easily held on to with your typical hard jaws. Does that make sense?
Yeah.
So let's do this. Save your work. File save.
I thought those went on the vise itself.
What's that?
I thought those were going on the vise itself.
They are. You'll see what I'm talking about here in a moment. So save your work and then open up the softjaw file. And I'm going to look at mine from an isometric. So hopefully you have access to it. So mine's upside down. If I wanted to, I could go back to the planes manager, make the top plane the active plane. Look at it from an isometric view. So hopefully you have access to it. Everyone's done it. Everyone's turned it into me. So you should have access to it. So open up, save your Crankcase project, and then open up the softjaw project. Go to the level manager. And I want you to make the solid model level the active level and make every other level invisible. And if I go to home statistics, I've got one solid, 24 operations, and 8 tools. So the only thing that's visible in my graphics area is the solid, and that's what I'm checking. I want to make sure that there's nothing else visible in my graphics area. Everyone good up to this point?
Yeah.
Okay, cool. So now go to File, Save Sum. Not save as, save sum. It says select the entities to save. Select the solid model, and then select End Selection. It brings up the Save As dialog box. What I want you to do is navigate to your Crankcase folder, your working folder for the Crankcase, and then save this as Softjaw for import. I'm changing the name. Softjaw for import. And then select save. Save some, saves only geometry, associated tool paths, entities will not be saved. That's fine. Select OK. How's everyone doing?
Good.
Nice. Oh, and on a side note, has anyone checked the schedule of classes for next semester?
It came up today.
Yeah.
I think, yeah, today. I haven't checked mine yet.
So let me pull it up for you guys real quick.
Mhm.
And this will be good news for, I believe, everybody. We go to students, schedule of classes. So this is on a side note, but I wanted to bring it to your attention. Go to search college class schedule. So going to spring 2021, City College, machine technology. And then I'll select search. So this is what I saw the other day, and I know several of you will be very happy to see this. So my class is being taught. I'm happy to see that. This class is going to be repeated, but none of you should have to repeat this. But the 170, 171, and 172 classes are being taught at night. And then the 150 class is being taught in the daytime. Let me see this real quick. Yeah, 150. So this is the introduction to CNC machining. This is a daytime class. I teach this at nighttime, but they're not offering it this in the spring term. This is the intermediate this is a follow-up course to the 150 class, and we have had people take this class before they take this class if they have some type of background. And because this is the only class being offered, I'm sure they will accommodate anybody that hasn't had the 150 class the best that they can. Corey, are you out there?
I'm right here.
Corey, have you heard anything from the instructors of these three classes?
Nothing direct.
Okay. So they are they're offering them, and it looks like they're going to make an attempt to teach these classes. These are on campus classes, so nobody knows what the future holds. If everything goes smoothly, these classes will be offered. There are things out there that might prevent this from happening, so everyone keep your fingers crossed. So
Question.
Yes. Who's got the question?
Are these classes going to be like, is the 170 the next class after this?
Not necessarily, because the next class after, or the 170 class is usually the 170 class usually follows the 150 class. There are no CAM classes being offered next semester according to this schedule. So you guys are going to have to wait until the summer or possibly the fall to continue with the CAM classes. But if you're motivated and you're more concerned about learning the software and learning more advanced tool paths or how to use the software better, YouTube is a great resource. There are a lot of resources on YouTube, or a lot of tutorials on YouTube with some pretty challenging projects. But with what's going on in the world right now, I'm thankful to see that they're offering some face-to-face classes. I'm not involved. I wish I was, but from a student's perspective, this is a huge improvement, because they were offering all lab classes again when they initially came up with the semester for the spring. But now they're offering face-to-face classes. Corey will be involved with that, I'm sure. So yeah, Corey. So Corey, as you get more information pertaining to these classes, please let us know.
Will do.
So just thought I'd throw that out there. What's that?
Those VTLs or what? Or still mills?
Oh, there are 3 Fidel vertical mills, and then there are 3 Haas vertical mills. We have a mini mill and then 2 VF2s. So there are 6 vertical mills, and these classes are all related to vertical mill. The lathe class is the class that would go over the lathe is not being offered next semester.
So even though it says the turning, there's no turning or whatever.
Where does it say turning?
Control turning centers, is that?
Where
Well,
I see it. Turning centers.
one, yeah.
Yep. So that's I didn't see that. They changed that. That's and they might have lost the lathe. I'm unaware of that. So as far as I know, those classes everything in that class will be taught. They'll be teaching mill or CNC mill.
That's cool though too.
So yeah, I didn't know they added the turning center 1 and turning centers 2 on that. Okay. So, but anyway, I thought I'd make you guys aware of that. And Zach was saying something about the missing. You should be able to. Can you guys register at this time?
No, we just got registration dates.
Okay. They might fill up quick, but I'm sure they'll take as many people as they can. But then again, it's hard for me to say, because if they limit the numbers due to COVID, that could be an issue also. So I'm going to class details, see if anybody's.
Yeah, my registration date's not till December.
Got it. And there's no class details popping up. There we go. They're going to take class capacity 20, available seats 20. So that's a lot of people for that class. I'm sure there'll be plenty of seats, and if you just get on, if you can't register, which I'm sure you'll have no problems registering for it, get on the wait list. Can we get away with taking the 170 without taking the 150 as a prereq? Probably. I know people have taken both at the same time. I don't recommend it, but you're gonna have to talk to the instructor because of the situation that we're in. They might try to accommodate as many people as possible, even though they haven't taken the 170 class. And once again, we're going to kind of rely on Corey. Corey, you out there? Corey.
Yeah.
Corey, can you do me a favor? Can you, I suspect there's going to be a lot of people trying to take the 170 class that haven't had the 150 class. Can you get any input from Arnell on that topic?
Yeah, I'll get some info from
It doesn't have to happen tonight, but like in the real near future, that'd be great. I mean, we're still 3 months out. If you look at the start date of this class, it's February 1st. Can you guys see my screen? February.
Yeah.
So we have all of like half of December and all of January off, and we're not even in November yet. So you're gonna have all November, December, and January before this class even starts, and hopefully things settle down before the beginning of the class.
And I'm noticing where it says enrollment requirements, it's just saying advisory. It's not saying,
it's not like if you register for math classes and you don't have the prereqs, it will not let you register for the class. Yeah. Whereas this is a highly recommended prereq, but not enforced. Does that make sense?
Yeah.
So, all right. So we'll get back to what we're doing here. So is everyone able to save this by using the save sum and then saving it to the Crankcase folder as Softjaw for import?
Yeah.
All right, cool. So now go back to file and we're going to open up the Crankcase again. Now it's asking us, do you want to save it? It's not necessary. All we did was, I'm not going to save this file, say don't save. So I'm back in the Crankcase file. Let's do this. We're going to import a solid part into this session of Mastercam. Now there's a specific way you have to do it without losing work. Go to File, and you're going to use Merge, not Open. You're going to use Merge, and this will bring another part into an existing existing Mastercam file. I've got Softjaw for import saved to my working folder, so here it is. If you saved it to a different folder, all you have to do is navigate to that folder. Be careful, do not bring in the Softjaw tool or Softjaw part with all the tool paths. You do not want that. That'll make a gigantic mess. This is Softjaw for import. All I'm bringing in is the solid model that we saved. I'll select Open. And kind of places it in a weird spot, but that's fine. And there's all these tools here where we can align, rotate, scale. I find it easier just to select OK. And then I'll use the dynamic move tool or dynamic translate tool to move the part. So how's everyone doing? I got a Softjaw sticking out of your material?
Yep.
All right, let's do this. Go to Transform. dynamic. Select entities to move or copy. Select the soft jaw. End selection. Now it's placing, we got a gnomon attached to our cursor. I'm going to lock on to the midpoint right here. If I look at it from an isometric view, it might be easier just to place it up here for now. Yeah, let's place it up here. Manipulate gnomon, select gnomon axis to edit or press apply OK to double click the mouse to accept the results. Grab the x-axis and move the thing away from the part. Now I'm going to do a series of rotations and moves to get it to where I need it to be. I'm going to rotate, I'm going to grab the green arrow and rotate it 90 this way. Then I'll grab the blue arrow, or the blue quarter sphere, or blue quarter circle, and rotate it 90 this way. Now this is something that takes a little bit of time getting used to. Then I'll select OK. Uh-oh. You have selected a solid to move, but you have not included the defining wireframe entities. If you do not include the existing wireframe entities, new ones will be created automatically and the original entities will remain. Okay, select yes. It didn't do any of that. Hold on. All right. Then I'll clear colors. How's everyone doing? So this is a little, this is challenging.
So you flipped, how do you flip it?
I rotated it so that the counter bores were facing the part. So you visualize these jaws in a vise. And let me pull up a picture real quick. I've got a picture, I've got several pictures of Kurt Weiss on my screen. And I'm just going to see if I can open up this one. So these aluminum soft jaws are going to replace these hardened and ground jaws. And what we're going to do is we're going to cut the profile. We're going to cut a 5-inch radius into these jaws so that when we clamp down on it, it locks onto. So did you select open or did you select merge, Tyler? Can you do that again? Yeah, I'll definitely do that again. You opened it. You want to select merge. So go back to open up your crankcase file again. Then go file merge. Just merge it. Okay, you're good. So what these soft jaws are going to do, we're not going to draw in the whole vise. I've got models of it, but it's not necessary. We're just going to draw in, or we're going to bring in the soft jaws, and then we're going to create the radius cut that's going to come into contact with the outer cylindrical face. So I'll do it again. So delete that. Now, it said I wanted to create some additional geometry. I'm not seeing anything. I'm waiting for it to appear. So I'm bringing in that soft jaw. File, merge. Be careful. You can merge existing Mastercam files on top of other existing Mastercam files. And if they have toolpaths and all types of other things, it gets really messy really fast. So that's why we opened up the soft jaw part, saved just, when I said save some, I saved just the solid that represents the soft jaw. And now I'm merging that soft jaw for import into this session of Mastercam. So soft jaw for import, I'll select open. And we could scale it, rotate it. There's dynamic, and that'll take you, but I'm just gonna select OK. And then I'll go to transform dynamic here. So dynamic, it's asking me to select the entity that I want to move. I'll select the jaw. I'll select end selection, and then I'll place this dynamic gnomon on the endpoint right here. If I left click on the green arrow, I can drag it away from the part, left click, and then using a combination of these quarter circles, I can rotate it to where it needs to be. So I'm thinking I'll grab this green quarter circle, rotate it 90. Now be careful, make sure you get it right on the money. You could type in 90 too. And then I want to rotate it so that the face of the open counter bores are facing the part. I'll select this blue circle. And once again, once I can see which direction the angle is going, because you can rotate it in the negative direction or the positive direction. I can see that it's rotating, or I need to rotate it in the positive. So I'll type in 90, hit enter, enter again. I'll select enter again. It's going to give me that warning about, do you want to move the defining wireframe entities? Yes. A little concerned about that. I'm wondering what's going to happen if I go back to the other file. And selection. So now I got this here. Not quite where I need it to be, but it's got the correct orientation. If I right click and then I go to let me see something. If I go to the view solids manager, yeah, I could remove the history from this thing, and that would eliminate that, well, not delete, but remove solid history. And that would take away this stuff right here. Let's see what it does. We'll leave the solid history alone for the time being. Right click, clear colors. So, Josh, were you okay with moving it like up to this point?
Yeah.
All right, cool. What we're going to do now, we're going to move it from the midpoint of this edge to the center down here. So this will be a little challenging. Go to, let's see here, transform, dynamic, select the soft jaw again, hit end selection. Now let your auto cursor lock on to the midpoint of this edge right there. Place the gnomon, select the sphere. Now you see how the whole thing is attached to your cursor. Tumble your view and lock on to the center here. And then select OK. And we're getting this warning again. So I'm going to delete the history from this. Right click. Remove solid history. Now it's just considered a brick. So this is what it should look like on your screen right now. Look at it from a top view. How's everyone doing?
Good.
Good. Okay, we're going to move it again. Go to translate, select it, and selection. And then along the y-axis, we're using the move method. Move it to 1.5. And the reason being is I want some material. I'm going to cut this radius on the soft jaw. And I don't want it to break through this wall. I want to have some support. I want to have enough geometry here to support this cylindrical part. So I moved it 1.5 and I'll select OK. And I'll clear the colors. How's everyone doing?
Good.
Good? Fong, how you doing? He asked me to do it again. I forgot to follow up with him. Good. Nice. All right. So we moved it 1.5 from the origin. So the distance from the center to this edge is 1.5. Look at it from a right side view. We're not holding on to anything. We need to move the jaw up a distance of 0.375. Go back to transform, translate, select the jaw, select end selection. Now you got to reference the direction of the axes. I believe the Z is what I want to move it in. So if I click on this, I'm moving it in the Z. I was referencing this coordinate system right there. So in the Z, I just started clicking this arrow. Change this to 0.375. And I'm in a translucent view. And you can see the bottom edge of the material. And what does this edge represent that I'm hovering my cursor over right now?
Counterbore.
That's the counterbore. That's the counterbore in
Yeah.
the jaw. I don't want to cut through this, so I want to make sure that when I look at it from the right side view, oh, lost it. So right side view, transform, translate. I'm moving it in the Z, 1, 2, 3. I can still see I don't want this in line with the part, or I don't want the actual part below the top of the jaw, and I don't want the jaw, or I don't want the material interfering with the counterbore. So I'll change the Z to 0.375, 3/8 of an inch. I still have clearance between the bottom of the part and the counterbore. And then you can see that the bottom of the material and the counterbore, I have clearance. And then the part is still above the soft jaw. I'll select OK. Right click, clear colors. And let's see here, right click. Right click isometric. Right click fit. How's everyone doing? You created another soft jaw? Intentionally, or are you disregarded? We're going to create one too. Okay, we're going to create another one also, but we have to do a few things to it first. So how's everyone doing up to this point?
Okay.
Okay, nice. All right, so good, or was that a question?
No, I think I copied it.
Let me see your screen. Hit isometric. Yeah, looks like you copied it. Not a big deal.
Yeah.
Just delete the one that's on the bottom. Just select the one on the bottom and delete it. Not the one. Yeah, you want the one that's intersecting, or yep, perfect.
Yeah.
Okay, cool. Yeah, so if you copied it, not a big deal. Delete the one that's not intersecting the part, and you're fine.
Yeah. I wasn't sure if I could still click on it like that.
Yeah, you're good.
All right, thank you.
You're welcome. All right, so back on my screen, what we're going to do now, we're going to use the material to cut away from the jaw. The problem is when we do that, the material is going to disappear. So I need an extra copy of the material. We're going to copy the material onto itself. Usually this is not what you want to do. So watch how I do this. And let me show you two different ways of doing it. We're going to go to solids and we're going to use Boolean. And where are they hiding that these days? Mm-hmm.
Isn't the first one
Right,
next to
it's right here. Yeah. So if it was a snake, I'd be bit. So select this, and it says select target body. So what are we trying to change? This is our target body. So this is the target of the Boolean. It says select tool body. Select the cylinder. Or tool body. Select. So let me select it. What's up with that? Oh, use remove, and then select.
You see how that square on the left is highlighted red? There's a
Yeah.
little arrow.
Yeah. So select tool bodies. So let me back out of this real quick. I might have followed the instructions incorrectly. So extrude, my bad. So Boolean, select target body.
His is blue.
And then select tool body.
The duration that needed.
I might have to change it. For some reason, it's not letting me select it.
No, you see underneath that red, the other tool body, there's an arrow that it says if you highlight the arrow.
Oh, got it.
Select, not that one, the other one.
Got it. Okay, I got you. Okay, so select tool body. This one right here.
Yeah,
Add selection. And I want to use remove. You see what it did? It took the cut out of the jaw. Problem is, the original item disappeared. So what we're going to do, back out of this, we're going to copy the material. And that's going to become the tool body for that Boolean operation. We need one to represent our material, and then we need one to cut away with. We could have done it a different way. I could have drew in a circle and then did an extruded cut with it. I just want to show you guys a different tool. So copy the solid that represents the material onto itself. To do that, go to transform, translate, select the material, change it to copy, actually, and selection, change it to copy, and then make the X, Y, and Z all set to 0. And then select OK. And what happened was we created a solid sitting on top of a solid. So there's actually two instances of this cylinder sitting on top of each other. I'm now going to use one to cut away material from this soft jaw. I'll go back to the Boolean tool. So solids, Boolean. So select target body. So I select the target body. Then so select tool body. I'll select this icon. I'll select one of the cylinders and selection and change it to remove. Select OK. And now if you go back to the level manager, one second. Okay, so from here, make the material level invisible. And if I make the and you'll see that we have the cut in the soft jaw. You make the material level visible again. This is how we're going to hold on to this cylindrical part in the vise. I'll look at it from an isometric view. And from here, I'm going to mirror this jaw to the other side of the part. I'll go to transform. I'll go to mirror. I'll select the jaw. I'll select end selection. And then you can see it mirroring about the x-axis. And that's what I want. If you wanted to mirror about the y-axis, you would just change it to y, but it does something completely different. It mirrors it on top of itself. So mirror it about the x-axis. Select OK. Right-click, clear colors. And where did they go? Right-click, clear colors. Right-click, isometric. Right-click, fit. And save your work. And it's asking me, yeah, so I'll overwrite the existing file. So how's everyone doing? Now, can you guys visualize? So if you look at our Mastercam file and then look at this picture, can you visualize these jaws being replaced with these jaws and us holding on to that 5-inch diameter by 3.75 long piece of material?
Yeah.
So that's how we're approaching this part. And something I would do now, I would move my coordinate system to this point right here. I would go back to my planes manager. While the first operation is selected, I can select this icon and I can drop my coordinate system for retrieving geometry from a database. Interesting. So let me try to save my work again. Hopefully I don't get that error again. So now you can see the coordinate system is there. If I wanted to, I can move it over here. But what I would do is I would keep it on the stationary jaw. If you're looking at this setup, this is the jaw that moves. This is the stationary jaw. So this will be, locked into position. I would put my coordinate system on the stationary jaw, and then I would set I could set my X0 off of this edge, Y0 off of this edge, and then I could actually set my tool lengths off the top of the jaw right here. How are we doing? Are you guys there?
Yeah, we're there. We're good.
All right, cool.
Yep.
All right. How's everyone doing? If you have any questions, feel free to ask. That's a little bit more advanced than what I've done in 160 classes in the past. But I like doing this project because it shows people how you might hold on to something that's not easily held on to with a typical hard jaw.
Makes sense.
Yeah, so it's just it's you got to hold on, and I don't want to say half the battle is, but one of the more difficult things that we have to figure out is how are we going to hold on to something when we machine it. Things aren't just held in held in space while we cut into them. They need to be securely held onto securely, otherwise bad things happen. Parts get pulled out of the vise, tools break, parts go flying. It's not so this is something that we have to take into consideration. With this particular setup, I look at it from a right side view, and then I change over to a non-shaded view. We're holding on to 3/8. So the distance from the top face here to the bottom face here, this is 3/8 of engagement coming out of that vise. So go back to a shaded view. I'll turn on translucency. That might be a little too much, so I'll turn translucency off. And then I'll look at it from an isometric view. If you haven't, save your work. So let's do this. It's pretty much 7 o'clock. Let's take 15 minutes. And when we come back, we'll start machining the part. Actually, we'll bring in the machine definition, and we'll create a few toolpaths tonight. All right?
Okay.
So let's take a break, and I'll start back up at 7:15. All right, so now that we have the soft jaws in place, let's talk about how we would go about machining them, because we load them in the vise, or we fasten them to the vise, and go back to level manager real quick. These cutouts, let's see here. Oh, and I should have created, I didn't realize it, but I should have created a level where these two soft jaws can reside. So let's do that real quick. Go to create another level, and I'll call it level 8 for the time being. We'll call this soft jaws. I'm going to place this piece and this piece on that level. So I select them, right click, let's select change level, and I'm going to place them, I'm going to move them to level 8. Now if I go back, I can turn the solid model off, I can turn the material level off, and this is what the jaws are going to look like when they're in the vise. But they don't have these this cutout for the 5-inch or for the 2.5 radius yet. So visualize these two soft jaws in the vise without these cuts. When you cut these jaws, you have to establish the distance from this point to this point. And you need to secure this jaw. This is on the movable jaw. And if I were to cut into this jaw, or into this jaw in our case, it's going to rattle, it's going to vibrate, and it's going to have a really bad surface finish, and it's probably going to damage the tool. So what we need to do is we need to establish the distance from this face to this face, and then clamp onto something that will secure this in place so it doesn't rattle or vibrate. You might remember that we initially placed this from the center, I moved it 1.5, and then we mirrored it. So the distance from this endpoint to this endpoint should be 3 inches. If I go to home, analyze distance, select this endpoint and this endpoint, the distance is 3 inches. So what I would need to do is I need to find something that's 3 inches, place it between these two jaws, and then tighten down on that 3-inch piece of material. Or what I like to use, or what I would use in this case, I would take a 1, 2, 3 block, take the 3-inch length of it, and place it in between the jaws, and then tighten down on it. You just want to make sure that the top of the block, or the top of the material, is below this edge right here, because when we're cutting out this profile, anything that's sticking up too high it will also get machined. Does that make sense?
Yep.
So yeah, and I've had people do this in the past where they cut a soft jaw and they don't secure the jaw on the movable vise, and it vibrates. They get a lousy surface finish, and usually it can damage the tool depending on the material that you're cutting. So in this case, what I would do, I would go to the toolpath manager, view toolpaths, and in addition to having my first operation, my second operation, I might have an operation dedicated to cutting the soft jaw. And we'll talk about that when we get to it. But we have several other things that we need to do prior to cutting the soft jaw. We need to bring in a machine definition, and I think that's pretty much it. Just bring the machine definition, then we can start creating toolpaths. So how's everyone doing up to this point?
Good.
Good? Okay. Let's do this. Let's bring in a machine definition. Before we bring in a machine definition, bring up the toolpath manager. Go to view, managers, and then make the toolpath manager visible.
Tyler just brought up saying, what about our initials?
Oh, yes. Good point. Let's backtrack a little bit. Let's put our initials on the part. So we'll need to determine where to place them. So let's go back to the level manager. And let's make the name level the active level. bring up the solid model. Trying to think of a good place to engrave our initials. I'm thinking somewhere on the, so do this, go to your planes manager, make the top plane the active construction plane. So just select top and then select equals and then hit isometric. I think we place our initials right here. And just to unclutter my screen, I'm going to make the soft gel level invisible for the time being, and I'll change over to a non-translucent view. We can place our initials at the center of this hole and then translate them so that they're right about here. I'm thinking that's as good a place as any, but that might not be a great place to put them. That might be considered a gasket surface. We're not actually building this, but for identifying it as yours, let's place the initials right here. If you were machining this part for that would actually go into an assembly, you might not want to machine this surface right here. There's probably going to be a gasket, and then there's going to be a cylinder sitting on top of it. But we'll place our initials right here. So make the name level the active level. Make the C-plane, set the C-plane to top. Go to the Home tab. Set your wireframe color to something that you'll be able to see with the current solid model color. I'm thinking I'm going to use, I can go back to, use this purple color right here. Got a couple other things using that color, but with the current background, I think that that'll work. Better yet, I'll use this orange. I'll go to wireframe. I'll go to create letters. Use Mastercam box font. So Mastercam box font. My first initial, my last initial. I hit enter. Not seeing anything, so go to the height. Change it to 0.5 for starters. And that's too much. What's 0.25 look like? I think 0.25 is better. I'll place it off of the part. And then I'll select OK. I'm going to draw in some construction geometry. It's going to be used to place my initials. I'm going to delete the construction geometry when I'm done creating it, when I'm done using it. Draw on a line. Go to line endpoint. Lock onto the 12 o'clock quadrant here. Then I'll lock onto the midpoint of, I think midpoint or perpendicular. Nope, use perpendicular. I don't think that worked very well. No, it didn't. Try that again. Yeah, perpendicular. What's that?
Why don't you select, those little circles on the bottom right?
Circles in the bottom right. Circles in the bottom right.
Translucent, or you can put that black wireframe looking, not that one, but the left one, that one. Not that one, that one.
Gotcha. Does it let you lock onto it at that point?
Yeah.
Nice. So, yeah, so I want to go from the quadrant right there and then perpendicular. Still, is it letting you guys lock onto that?
No, see the solid one, not that one.
This one right here.
Yeah, I clicked that one and I was able to lock on to something right there.
Yeah, well, you got to watch out because you don't want to lock onto the midpoint because it's a diagonal. It's an angled line at that point. I'm trying to lock on. I want it to be perpendicular.
Okay.
So I could eyeball it for what it is. I'm just going to eyeball it. Not that big of a deal. And then I'll go back to this view. It's close enough. And if you wanted to get really, You could lock on to that endpoint, and then if I were to redraw it, now that it's considered real geometry, if I go to line, I can go to the quadrant, and still not, it's perpendicular to the first endpoint, but if I go to, where is it? This gear, selection settings. Oh, not that one.
What about the angle? What if you set that to 90 degrees? Would that be
But I'm trying the length.
oh, the length?
Yeah, so if I select perpendicular from the auto cursor, then it's gonna make me select an entity. There you go. So that way worked. I'll do it again. So what I had to do is, and maybe I don't even need that line. If I go to line endpoint, I lock onto the quadrant, and I want to make it perpendicular to that edge, that works. And then this endpoint is perpendicular to that selected edge. So there's a lot of tools. Just, with time using the software over and over again, you're going to become familiar with them. From here, I'll move my initials. I'll go to transform. A window, select my initials. I think I did that in the wrong order, but transform, translate. And you'll see a center point appear, or you'll see this control. Lock onto the center. There we go. It's not showing me a preview. That didn't work out at all. Try that one more time. Transform, select. Reselect. Then my cursor lock onto that point, and then lock onto the midpoint of that line. I'll use the move method. Then I'll select OK. I'll do that again. So I want to move my initials from the center of them to the midpoint of this line. I'll go to transform, translate. I'll select my initials. I'll select end selection. And then I'm going to use the vector from /2. And now I can zoom in, get this thing out of the way, lock on to the point. You'll see like a rubber band attached to the point, and I'm going to lock on to the midpoint of this construction line. I'll select OK. I can right click, clear colors. And then I'll delete this line. My initials are 1/4 inch tall. Once again, I just want to mention that you probably would not want to engrave on this surface, but for what we're doing, this is for identification purposes. We're going to engrave our initials on that top face right there. And from here, I'll just make the soft gel level visible again. I'll make the wireframe from solid level, the active level, and visible. I'll make the name level invisible. And I think we're good. And I don't have the material level visible, so I'll make the material level visible. I'll go to the planes manager, make the first operation, the active tool plane, active construction plane, and the active WCS. Now, if I look at it from an isometric view, we're looking at it as if we were seeing it sitting in the machine. This would be a good time to save my work. How's everyone doing?
Good.
Good? Nice. Anybody having any issues, any questions that I can field, or any problems I can help resolve? All good?
Yep.
Nice. All right. So now let's go to the toolpath manager. If you don't have it visible, bring it up. You might need to go to view, under manager, select toolpaths. Currently don't have a machine definition selected. So we're gonna have to pick a machine definition. I'll go to machine. I'll go to mill. I'm going to select the default mill. And that puts a default machine group in our toolpath manager. Before I make any changes to the machine definition, I'm going to set up my project manager. I'll go to File. I'll select Project Manager. And where it says Project File Folder, this is where the current Mastercam file is saved to. I would also like to have my NC files and my NCI files saved to that location. I'll select OK. I'll select the back arrow to get back to Mastercam. And from here, we're going to make some changes to this particular machine definition. Inside of the toolpath manager, underneath the machine group 1, you'll see properties. Expand the properties, select the plus sign. Then select files, the files underneath the properties. So I select files, then it brings up this page. Let's start by renaming the machine group. We'll call it Haas VF2. We'll need to edit the machine definition, select edit. And in this field, you'll see mill spindle group. Expand it and keep expanding it until you see tool spindle. Once you see tool spindle, double click on it. It brings up this page. Set the maximum spindle speed to match the capabilities of your machine. So we have 2 VF2s that are capable of 10,000 RPM. One's capable of more than 10,000 RPM, but we don't run it any higher than that. So set the maximum spindle speed to 10,000. And then select OK. If you were sending this part out to a machine that had a lower RPM capability, you'd want to set it to match that machine. So in this case, 10,000. I'll select OK. I'll select OK again. And that'll complete all the changes that we need to make on this page. From here, I'll go to Tool Settings. The default program number. This will be a 4 to 5 digit number of your choice. This will be the O word at the beginning of your program, or also referred to as the program number. Do not use 2000 series and do not use 9000 series with the Haas machine tool. Those program numbers are reserved for, I believe, Renishaw subprograms. So steer clear of using those. I'm going to call this 8000. For the feed calculation, I'm going to select from material. For the toolpath configuration, I'll check assign tool number sequentially. I'll check warn of duplicate tool numbers, and I'll check use tools, step back and coolant. From here, go down to sequence number. Let's start with 1 and have them in increments of 1. These will be the line numbers inside of our NC file, and they'll be numbered N1, N2, N3. And depending on the machine that it goes to, it might be numbered slightly different, but these will be the line numbers. So we'll start with 1, and then they'll be in increments of 1. For the material, the drawing isn't calling out what this material is made, or what this part is made from. We've made it from aluminum 6061 T6. So let's set our material to that. So I'll go back into Mastercam. Let's start by selecting the material. So for material, go to select. Currently it's aluminum inch 2024. To add 6061 to it, right click, select get from material. I'm sorry, get from library. And then select aluminum inch 6061. I'll select OK. I'll select OK again. You can now see the current material is aluminum inch 6061. We'll now edit this material definition. Select edit. If you needed to change anything with the title, you could make a change here. I'm going to type in -T6. I'll set the base cutting speed to 300. And I'll leave the base feed per tooth. We'll set that inside of the parameters for each toolpath. So for now, I just set the base cutting speed to 300. For the percentage of base for drilling operations, set this to 50. So left click on 60, hit enter, type in 50 and hit enter again. So when Mastercam calculates our RPM, it's going to use a SFM of 300 for end mills, and it's going to use an SFM of 150 for drills. From here, I'll select OK. That completes all the changes that we need to make on this page. From here, go to stock setup. Set your stock plane back to top. Select OK. For the shape, we have a solid model on our screen that represents our material. So I'm going to select solid/mesh. I'll use this icon to get back into Mastercam and pick select the solid that represents our material. For display, I'll check display and then I'll select solid. And from here, I'll select OK. Now, you'll see that the appearance of our material has changed. Reason being is I've got stock display turned on. If I go back to the level manager and I make a material level invisible, you see this shaded or this translucent representation of our material. And this will be our material inside of Verify. Everything appears to be correct. I'll toggle the display off, and then I'll bring back the material level and I'll change translucency. Or I'll turn translucency on. From here, I'll select isometric and I will save my work again. How's everyone doing?
Good.
Good?
Good.
Nice. All right, so let's do this. Let's go back to the toolpath manager. Before I start bringing in toolpaths, I'm going to rename the default toolpath group. This is actually going to be a 3-operation part. We're going to machine the first operation where we're holding on to around 3/8 of the material. When we get done machining the first operation, we're going to flip it over and then hold on to the part and the vise. We're going to take out these jaws and put in some hard jaws. And we're going to machine away the excess material that we're holding on to for the first stop. And then we're going to spot drill, drill tap, spot drill, drill. And we actually have a fillet on the outer corner. So we'll use a radius mill to create that fillet. And then the third op, we're going to bring in a fixture that's going to hold this part on a rotary or a HRT 160. It's basically a 4-axis that indexes about the x-axis on the machine. And we won't go into that tonight, but I'll show you some examples of what it looks like when it's on the machine. We've actually cut this part before. I've cut this part before, and I have a bunch of photos and videos of the machining process. Let's see here. So let's go back in and let's change the default toolpath group name to first operation. So right click, groups, rename, and we'll call this first operation. How's everyone doing?
Good.
Good. All right. So if everyone's good up to this point, let's create a stock model that reflects what the material is going to look like before we do any machining to it. So insertion arrow is underneath the first operation. Really can't be anywhere else at this time. Well, I guess it can. It can be in front of the first operation. So make sure the insertion arrow is under the first operation. Go to stock model. And for the name, call it raw material or raw stock, something like that. Set the stock plane to top, or deselect stock plane, and then it becomes top by default. For the initial stock shape, I'll select model. And then I'll use this icon to get back in the Mastercam and select the solid model that represents my material. So I select that icon. I'm back inside of Mastercam. I'll select the material. I'll select end selection. And that should be all that we need to do for this first stock model. I'll select OK. And then if I go back to the level manager and I turn off the material level, and I'll also I'll turn off translucency. There's our stock model that represents our material. To toggle off the visibility of the stock model, I need to go to the toolpath manager. With it selected, I'll select toggle display. I'll go back to the level manager and I'll make my material level visible. And then I'll change the translucency again. So we got a lot going on with the stock models, the material, the solid model that represents the material, and the stock model for verify. Sometimes it's a little confusing, keeping those three separate in our minds. How's everyone doing?
Okay.
All good?
Yeah.
All right. So we're not going to go into machining the soft jaws tonight, but let's assume that the soft jaws have already been cut. Where would you guys want to go to next? What do you guys want to do? Just think about what we've done with our previous projects. We've got 20. What's that?
I have a question.
Yes, sir.
Since I still see my wireframe geometry on the top of my stock model, does that mean I clicked in the wrong spot, or?
Let's take a look at your screen real quick. It might just be showing through, but I remember looking at your screen and you had 20 thousandths from, 20 thousandths extra added for the material beyond your parts, beyond the face of the part. So if you could show me your screen, I'd like to see what you're talking about. Look at it from a right side view or a front view. Either one will work. And zoom out a little bit. And then zoom in and turn translucency on. And then zoom into that top edge. No, I think you're good. I think it's just kind of, for whatever reason, it just kind of shows through from time to time.
Okay.
I think you're good. Now tumble your view a little bit. Yeah, go back to a non-translucent view.
Oh, there it goes.
Yeah, I think it's a refresh thing. Yeah, so you zoom in, you zoom out, it kind of appears, disappears. I can't, sometimes it does things, and after I realize that it's not an issue, I try to forget. I don't concern myself with the reason why. Sometimes it happens too often. It'll make you crazy.
Yeah, it does that.
Yeah. So
Thank you.
all right, cool. We'll go back to my screen. And here comes trouble. Hold on. All right, so back on 1 second. I'll be down in a minute. I'll be down a little bit. There you go. Give me 1 minute. I've got a visitor. Dude, go.
Okay.
Sorry about that. All right, back to where we were. Okay, so I'm going to go back to the toolpath manager. And we're going to create our first toolpath. And I'm thinking we take a 3-inch face mill and take 20 thousandths off the top of the material to have a nice machine surface on the top of the part. So I'm going to go to the tool paths. In the 2D section, I'll select face. And right now, the material is a solid. So for the chaining dialog box, I'm going to change it over to solids. Now I'm in solid chaining mode. The mode's set to C-plane, and then I've got loop and face selected. If you position your cursor on the outer edge of the material, left click, you can see that the outer edges become selected. I'll select OK. And that brings up the parameters for our facing operation. How is everybody with the selection of that top face?
Good.
Good? Okay, cool. I don't have a decent tool definition yet, so we're going to use a default one. I apologize. I know I've been talking about bringing that in. Haven't done it yet. So go to tool. We're going to bring in a 3-inch face mill. So select library tool. The filter is active from the last time that I used the facing operation, but if you're seeing every tool that's available from the library, go to filter. And before you do that, make sure you have filter checked, or filter active is checked, select filter. You might have all tool types selected, so select none, and then select face mill. And if you leave the tool diameter set to ignore, you're going to see all face mills coming out of that library. I'll select OK. I'm going to select the 3-inch face mill. You'll notice that it's 324 coming out of the library. When I double click on it, it should be added to your tool list as tool number 1. If it's not, you're going to need to go back to the tool settings and check assign tool number sequentially. So I've got the 3-inch face mill added to my tool list. I'll need to make some changes to this tool. Right click, select edit tool. Horrible representation of a face mill, but we're just going to go with it. From here, select next. For the number of flutes, set it to 6. You can calculate the RPM. You can see RPM is being calculated off of that 300 SFM.
I have a question about the number of flutes.
Yes, sir.
Would you use more flutes for roughing or finishing, or does it matter? Or?
Usually I use what I got. Face mills are not cheap. So the number of flutes, what I would be more concerned with would be the type of insert as far as surface finish is concerned. And it all depends on, you're gonna get a blueprint. And if it's a critical surface where the surface finish is, has to be of a certain type, it's a critical surface finish, then you might want to take into consideration the tool type and then the speeds and the feeds. You increase your feed, the surface finish is probably going to be a little bit rougher. So depending on what the requirement of the part is, if there's a big thick gasket going on there, they might not care that much. Does that make sense?
Yeah, because I was trying to read up on it, and it was saying like, the more flutes is like it gives you less like chip load because you don't have enough chip evacuation coming out the
it depends on the tool. Usually though, the increased number of flutes or an increased number of inserts allows you to increase the feed rate because you're spreading that chip load out between multiple flutes. So more flutes usually means higher feed.
Okay.
But the situation could, it's not set in stone. The situation is going to, determine what you use.
So if we set a certain number of flutes, and then someone else is going to go set up the machine, would they have to know that, or would they just use whatever they know from experience?
No. Your speeds and feeds are based off of the number of flutes and the number of inserts that you're using. So they're going to have to use the tools that when you program a part, you're going to provide them with a tool list that they're going to have to use when they set the machine up. They're not just going to blindly set the machine up. So you can create setup sheets, and you probably see like a job traveler or a setup sheet when you're setting up a job.
Yeah, we have those.
Yeah, so hopefully all that information has been determined by the powers that be, or the programmer in this case, and you're just gonna, and a lot of the times the tools that they use are the tools that's available. Does that make sense?
Yeah, because I've noticed. I mean, I haven't really done much mill work or anything, but I know they usually say what type of insert and whatever,
Yep.
and what type of tool you're using and how you're going to use it. But I'm running this old job on a tree mill, and it just says the tool. It doesn't say the number of flutes or anything like that. But
somebody should be giving you that information.
Okay.
Yeah, because if somebody else is writing the program and you're setting up the job, there's a good chance there might be a dedicated face mill to that machine.
Okay.
And the programmer knows what tools are usually used in that machine. Like I've been in shops where tool 1 through 15 never change because they're just always there, and the programmer has a tool list for that specific machine. Does that make sense?
Yeah, for sure it does.
Yeah. Okay. So depending on, they might have like the place where I work, tool 24 is the probe that's always there, and then like tool 20 would be the face mill that's always there. So that we have the 3-inch face mill in the tool 20 slot, and you just, depending on what will usually change is the insert, depending on the material that's being cut. Okay, so I got 6 flute. I've calculated the RPM. Let's turn the coolant on. Let's select show more options and then set the flood coolant to on. I'll select OK. And that'll be all the changes that I need to make to this page. So I'll select finish. Let's see here. The SFM, we can see that the spindle speed is based off of this SFM. Now, usually I would use a higher SFM for face mills, but not to complicate what we're doing, let's just go with the 300. For the feed rate, let's set the FPT to, what have we been using for our face mills? 5% of the tool diameter, or 5 thousandths?
I'm not too sure, but I don't know if we've ever used that.
Okay, so let's use 5 thousandths for the FPT, 0.005. And usually this information will come off of the box of inserts that the inserts came in.
Yeah, we use 5,000.
So yeah, this will be, usually they'll give you a range and they'll say, okay, for this type of material, use an FPT between 3 thousandths and 8 thousandths. And what I usually do is shoot right down the middle. And then depending on what's happening at the machine, I might make adjustments. So for the plunge rate, let's set it to half the calculated feed rate. So 11.46, divide that by 2. I have rapid retract selected. And in the comment field, usually you don't have something already entered here. So I'll borrow the tool name. I'll paste it down here. Say face top of part. We're going to skip over the holder. I don't have that defined yet. Go to cutting parameters or cut parameters. Now the part is wider than the cutter, so we won't be able to use one pass in this case. So for the style, set it to one way. I changed my approach distance to 10% of the tool diameter. I changed my exit distance to 10% of the tool diameter. So if you find yourself changing these from 50 to 10, change it to 10 and then select save. This icon right here. I'm going to deselect reverse direction of last pass. And then I'll make sure that the stock to leave on floors is set to 0. Depth cuts is turned off. I'm only taking 20 thousandths of material off the top of the part, not much at all. So I'll leave depth cuts turned off. Go to linking parameters. Set your clearance. Now this is going to be a little confusing. We want the clearance to be 2 inches above the top of the part. The origin, so if I set 2-inch absolute, is that going to give me enough clearance?
No.
No, because remember our origin is right here. The top of our part is slightly above 2 inches. So what I would do in this case, I would set it to absolute. I would select the clearance icon. And then I would let my cursor lock onto something that represents the top of the material. It places that value in this field. And then I'm going to add +2. So now this clearance is 2 inches above the top of the material. For the retract, it's 0.25 incremental. This will probably work, but I'm going to turn it off for now. I'll set my feed plane to 0.1 incremental. That's relative to this top face. For the top of the stock, I've got it set to absolute. I'll select the top of stock. And then once again, I'll lock onto the top of the material. Now you'll notice that the value is already there before I select the top of stock. That Z value is coming from the chain that's driving the tool path. So when I selected that top edge, it automatically placed that value in this field. For the depth, I'll set it to absolute. I'll select the depth icon. I'm going to zoom in, and you might have to change over to a translucent view. I'm going to zoom in and let my cursor lock onto the top edge of the part. And if we did everything correctly, the difference between this value and this value should be 0.02. And that should do it. I'll select OK. Look at it from an isometric view. I don't see any issues with the toolpath. From here, I'll run it in backplot. Let's speed it up a little bit. Looks decent. I'll exit out of backplot. I'll hide the toolpath. I'll look at it from an isometric view, and I'll save my work. Now, I haven't run it in Verify yet. It's 8 o'clock. I'm going to take a roll, and we're going to get out of here. We had a marathon session tonight. Pretty much, with the exception of that 15-minute break, we went nonstop. So we're going to stop here for tonight, and we'll pick up here next class, and we will run it and verify. We'll create the stock model. We'll continue on creating toolpaths for the first operation. So save your work, and we'll pick up here next class.